Hello everyone, Mr. Sutherland here to do our notes on the beginning of section 6.3, which is on trig functions of any angle. You'll notice this time I've pre-written a lot of the definitions, some of the problems, so that I can make sure I have time to do the problems and explain the problems. My time limit on these videos is at most 15 minutes, and my goal is to try to get everything accomplished in that time. So pause as you need to throughout to copy things down. So what I thought we would do first is a review problem. So let theta be an angle in standard position. 0.16 is on the terminal side of angle theta. Find the 6 trig ratios of theta. So go ahead, pause the video, sketch this out, and see if you can find the 6 trig ratios based on that information. All right, so let's see how you did with this problem. So we have our angle is in standard position. So what that means, remember, is that the initial side, vertex is right here at the origin, the initial side is on the x-axis, and the terminal side goes to the point 1,6. So if I think of 1,6 being right here, there is the terminal side of our angle. And we want to find, if this is theta, we want to find the value of the trig ratios of that angle. Now this fits into what we've been doing previously because it is an acute angle, less than 90 degrees. We're going to start looking at in this section having the angles in quadrant 2, 3, and 4 and how that changes the values. But first thing I'm going to do here is just make my right triangle. We know that the x value is 1, so that would be the base there of the triangle. The height of the triangle would be 6. And if we use Pythagorean theorem with 1 squared plus 6 squared equals c squared, we get that the hypotenuse of this triangle is going to be square root of 37. So we now can go ahead and find our ratios. So we have sine, cosine, tangent. We'll do those three first. So remember, sine is from our angle, which is here, the opposite over the hypotenuse, so 6 over root 37. If the problem tells you to rationalize, what that means is you're going to multiply top and bottom by root 37 so that you can have a square root not in the denominator. So 6 root 37 over 37. Cosine would be 1 over root 37. So if we do that same rationalizing with this one, we get square root of 37 over 37. And then tangent would just be 6 over 1. Now, let's see if we can remember our reciprocal function. So with sine of theta, that one is always paired with cosecant theta. And cosecant's the reciprocal of sine, so root 37 over 6. Secant of theta is the reciprocal of cosine, so root 37 over 1, which is just root 37. And then cotangent of theta is the reciprocal of tangent, so 1/6. So there are the 6 trig ratios for theta. Now, if we were to look at any angle, let theta be any angle in standard position. Let P of xy be a point on the terminal side of theta. But we're not restricting theta this time to the first quadrant. So if I were to draw a xy coordinate system and draw an angle in standard position, we would have the initial side on the x-axis, and let's put the terminal side in the quadrant 2, and let's have this be my point xy. So this is theta. So what we can use to find the trig values of theta is we build the right triangle always with the x-axis. This is my distance for x. This is my distance for y. Now, since it's in the second quadrant, x would be negative if I had a number here, and y would be positive. And what we're using, this angle, when we start doing numbers, we're going to call that angle a reference angle. And then for the hypotenuse, we're going to call that r, where we know that x squared plus y squared equals r squared. So r is just the positive square root of x squared plus y squared. The r value, no matter what quadrant we're in, is always going to be positive. So sine of theta is going to be opposite over the hypotenuse. So y over r. So cosecant theta is r over y. Cosine theta is x over r. Tangent theta, secant theta would be r over x. Tangent theta is y over x. Cotangent theta is x over y. Now notice, sine of theta, r is always positive. So the sign like positive, negative of sine depends on the y value. So in quadrants 1 and 2, sine is going to be positive. In quadrants 3 and 4, sine is going to be negative, because the r value is always positive. So we just have to worry about the y value. Cosine is going to be positive in quadrants 1 and 4 when x is positive, and negative in quadrants 2 and 3. And tangent is going to be positive when sine, or y and x, are the same sign. So in quadrant 1 and 3, and it's going to be negative when they're opposite signs. So 2 and 4. And that's something to come back to as we're evaluating these problems. So let's look at an example that will use this. So example 1 says, let the point negative 5, 2 be a point on the terminal side of angle theta in standard position. Find the 6 trig ratios for theta. So we have the point is negative 5, 2. So about there. We have our initial side. This is our terminal side. And so now, and this is our point, negative 5, 2. Now I'm just going to build my right triangle here. Now, this is theta, but we use this triangle to find the values for the theta. Even though this angle isn't theta here, we can use that triangle we've built to find the trig functions of theta. So I have the x value is negative 5, and we got to keep that negative there. The y value is 2. And then we have the hypotenuse. If I were to do Pythagorean theorem, you would have square root of 29. And so when we find these values, sine of theta is the y value, which is 2, over the hypotenuse. And if we were to rationalize, it'd be 2 root 29 over 29. Cosine of theta is negative 5 over root 29. So negative 5 root 29 over 29. And tangent of theta would be negative 2/5. Now notice, we are in quadrant 2 here. Sine should be positive, and it is. Cosine and tangent should be negative, which they are. And then we can do our reciprocal functions. So cosecant would be root 29 over 2. Secant would be negative root 29 over 5. And cotangent is equal to negative 5 over 2. Second and final example for our notes today. Let cosecant of theta equal 4, and cotangent of theta is less than 0. Find the remaining trig ratios. So pause the video and explore this problem. See what you can come up with, see what you can try, and then I will be back to go over it with you. Okay, so let's see what we have here. A little different form than example 1, but using some of the same ideas. So we have that cosecant is positive 4. Now the mistake people make with these is they automatically draw every triangle over here in quadrant 1, but we don't know for sure that this triangle is in quadrant 1. It could be in any one of these 4 quadrants. Now, cosecant is the reciprocal of sine, and it's positive. So we know sine is positive in quadrants 1 and 2. So I'm not going to draw my triangle in quadrant 3 or 4. Our next clue of which quadrant we're going to draw the triangle in is using this statement here. This says cotangent is negative. Well, cotangent is not going to be negative in quadrant 1 because x and y are both positive, and a positive divided by positive is positive. So our triangle has to go here in quadrant 2. And now I can label so really theta is this angle here going around. We think of all this kind of drawn in here. Cosecant is the reciprocal of sine, so it is hypotenuse over the adjacent side. And we just remember this is really 4 over 1. So here's 4, here's 1. And if we do Pythagorean theorem, right, 1 squared plus b squared equals 4 squared, we get that the missing side here is root 15, but it can be negative because we're a negative x value. Now, once we have that, we can do our 6 trig ratio. So sine is the y value over the hypotenuse over r, so 1 over 4. Cosine of theta is the x value over r, and tangent theta is the y value over the x value, which if we rationalize becomes negative root 15 over 15. Cosecant we already had. Secant of theta is going to be 4 over negative root 15, so negative 4 root 15 over 15, and cotangent of theta is equal to negative root 15 over 1, or just negative root 15. So the change we're making from what we've done previously with right triangle trig to today is we are now looking at that angle occurring in any of the 4 quadrants. And what we will then do next time is come up with a set of values that we can find the trig ratios of a certain set of values based on our special right triangles, and that will create what we call the unit circle. But that's what we'll work on next time. Thank you. Bye.